Hi, in this video, I'll talk about the descriptive aspect of the binomial probability distribution, its graph, mean, and standard deviation. Let's suppose our variable x is binomial with n equals 100 and p equals 0.2. That means you run 100 independent trials where each trial has a 0.2 or 20% chance of success. On the horizontal axis, x represents the number of successes in this set of 100 trials. And vertically, how high a bar is represents how likely you get that number of successes. In theory, you could get 0 successes, or you could get all 100 successes. They are possible, but what's likely is that since each trial has only a 20% chance of success, then overall, gonna get about 20% of 100 successes. You're likely to get around 20 successes, meaning the mode of the distribution will be about x equals 20. And then it becomes less likely from then down, so the graph looks like this. The mode of the distribution will be around 20, and the skew will be on the right. For b, n, comma, p, with small p, p less than 50%, then the graph will be skewed to the right. And the mode will be on the left. Vice versa, if x is binomial with n equals 100 and p equals a large number, let's say 0.8, then the reverse story happens. The mode will be around 80. And the tail will go off to the left. So for b, n, comma, p, with p larger than 0.5, then the graph will be skewed to the left with the mode is on the right. Whereas for a binomial, where p is 0.5, exactly half and half, then the graph will be nicely symmetric. Next, let's talk about the mean. Suppose your binomial distribution is b 50, 0.1. We're going to compute the mean by remembering that the mean is equal to the expected value. You have 50 trials, and each trial has a 10% chance of success. Then how many successes do you expect? Well, you expect 10% of the 50, which is 5. In general, for b, n, comma, p, the mean is going to be number of trials times the probability of success. Now, standard deviation. I won't prove this. I'll just tell you what it is. If I ever make a video proving it, I'll put the link up here. For b, n, comma, p, the standard deviation, sigma, is equal to the square root of n times p times 1 minus p. P is the probability of success, 1 minus p is the probability of failure. N times p times 1 minus p. That's the standard deviation. The variance is just the square of the standard deviation. So sigma squared is equal to np 1 minus p. So here's the summary of everything. Hope that helps. Subscribe for more contents. Bye.